Okay, now it's time for trig functions defined on the unit circle. So we're going to go ahead and we're going to suppose that the real number t corresponds to the point P on the unit circle. Evaluate the six trig functions of t. Okay, so let's draw. So here we have a point. X value is -2/3. Y value is square root of 5/3. Okay, so basically this is what we have. Something here. About that. This is my point. We have a circle. Okay, so suppose that the real number t, which is starting from initial side right here, x-axis, all the way to the point -2/3, -5, square root of 5/3. Okay. On the unit circle, evaluate the trig functions. Okay, so first we're gonna find the sine of t. Okay, go back to SOHCAHTOA. Okay, so sine of t is opposite over hypotenuse. Okay, but instead of going back to that, we're actually just gonna do the y value. Keep it. It's always good to have that just in case though. Okay, so what is the y value of this point? -5/3. Cosine of t, what is the x value of this point? -2/3. It's given to us. What is the tangent of this real number t? That would be sine over cosine, or y over x. Keep change flip. That'd be negative square root of 5/2. Actually positive, because a negative times a negative is a positive. Okay, shouldn't have erased that because you're gonna get the inverse functions. Okay, so I mean I have it here, but when we did sine of t, we got negative square root of 5/3. So therefore, cosecant, which is the inverse of sine, would be the flip of this. So it would be -3 over square root of 5. Of course, we have a square root in the denominator, so we want to rationalize that. So we're going to multiply by the square root of 5 on top and bottom. That'll give us -3 square root of 5 over the square root of 5. Okay. Earlier, we got that the cosine of t is the x value. And so how would we get secant of t? Just flip it. And last but not least, tangent of t, we got that it was sine over cosine, y over x. And so for the cotangent, you would flip that, which would be 2 over the square root of 5, and then of course rationalize that. So that would be 2 square root of 5 all over 5 for cotangent. Alright. in this section, we take a look at the unit circle, which in 5.3 I actually drew and spoke about, so you can take a look at that again if needed. I do recommend to draw the unit circle, so practice on a sheet of paper, then check yourself and see if you got it. Okay, so moving on to example 2, we're gonna evaluate some trig functions. So now we're given that t is 5 pi over 3. And using the unit circle, okay, we're going to get the 6 trig functions again. Okay, so let's put them over here. So sine of t, cosine of t, tangent of t. I always like to do it in this order. Sine, cosine, tangent. Tangent is just sine divided by cosine. And then we'll get the cosecant, which is the inverse. Secant, which is the inverse of cosine. And cotangent, which is the inverse of tangent. So, good practice. Alrighty, so on the unit circle, drawing 5 pi over 3. So here we have 30, which is pi over 6, 45 degrees, which is pi over 4, and 60 degrees, which is pi over 3. So if we were to draw this out, which I told you guys the trick to do this, we have you add 30 degrees, then 15, 15, 30, and so on. Okay, so here would be 2 pi over 3. Here we have 4 pi over 3, and here we have 5 pi over 3. Okay, so it's in the 4th quadrant. Okay, and in case you're not sure how I did that, so you start off with pi over 3, and then you continue until you get to 2 pi. So then next would be 2 pi over 3, which is right here. Then 3 pi over 3, which is pi, which is already here, so that's why I didn't write it. Then 4 pi over 3, basically the numbers that don't simplify would be the fractions in the quadrants. So here 4 pi over 3, that doesn't simplify out, that would be the next radian over here. And then 5 pi over 3 is the following. And of course, if you get 6 pi over 3, that's 2 pi, which we already have 2 pi right here. So we are done with 1 revolution around the circle. Okay, so that goes back to the trick of the 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. So you'll be able to see exactly where the denominators of 3 are at. Okay, so I can see that it's right here. And remember that the x and y values are the same. The only thing that changes is the signs based on the quadrant. So over here for pi over 3, we have 1/2 as the x value and the square root of 3 over 2 as the y. So in the 4th quadrant, the x values are positive and the y values are negative. So it would be 1/2 and then the y value would be negative square root of 3 over 2. Okay, so for the sine, it is just the y value of negative square root of 3 over 2. For cosine, it is the x value of 1/2. Okay, tangent is sine over cosine. So over here, it would be sine over cosine, okay, which is keep, change, flip. That's just negative square root of 3. I'm gonna erase this portion. Alright, for cosine, just flip sine. And then of course rationalize when needed. secant flip cosine, so that's just 2 over 1 or 2. And then for cotangent, flip tangent, which we got -3, negative square root of 3 or negative square root of 3 over 1, same thing. So if you were to flip it, it would be -1 over the square root of 3. You would have to rationalize that. And you're done. Okay, so you can do the same exact thing for part B. We're not going to do every single trig function. We're just going to make sure that we at least know which angle corresponds to it. Okay, so we might need to find a coterminal angle to find it. Okay, but we're still going to be using the unit circle to answer this question, make it a lot faster for us. All we need to know is the coterminal angle, right, between 0 and 2 pi in order to find the x and y coordinate of the point on the angle formed. Okay, so here, if you were to add 2 pi, remember that you want to have the same denominator as given. So if the denominator is 4, we're going to write 2 pi as 8 pi over 4. Okay, so these are equivalent. But now we have the same denominator in order to add. So when you add, what's -5 plus 8? 3. So this is 3 pi over 4. Okay, so now we need to find 3 pi over 4 in the unit circle. Okay, so pi over 4 is right here. Again, if you use my trig, pi over 4, the next would be 2 pi over 4. But if you simplified that, that'd be pi over 2, which is already here. The next would be 3 pi over 4, so that would be the following fraction with denominator of 4. Okay, so that would be in the second quadrant. Okay, so in the second quadrant, look at the x values. The x values are always negative and the y values are always positive. Okay, so it's going to be the same exact x and y value as pi over 4, which you should know the first quadrant by heart. Then the 3 pi over 4 would be negative square root of 2 over 2 for x, since the x values should always be negative, and then positive square root of 2 over 2 for the positive y values. Okay, so this is what we need. This is the points, x comma y. Okay, using that, we're gonna get, well, at least get the first 3, which is sine, cosine, tangent. Then you can practice getting the inverse functions, which is just the flip or reciprocal of them. Okay, sine is just y, the y value. Cosine is just the x value. Tangent is sine over cosine. So sine over cosine, y divided by x. That would be keep, change, flip. Don't forget the negative. Okay, so this all cancels and you're just left with -1. Okay. Those are the main 3. Okay, you can do this to check yourself, but the cosecant of t is the inverse of sine. Always rationalize. Right, because sometimes it becomes pretty. On the denominator, what's the square root of 2 times the square root of 2? That's the square root of 4, which is 2, and here we actually have a 2 in the numerator and denominator, so it cancels, and you're just left with the square root of 2. For secant of t, it's just the flip of it, so it's going to be the same thing but negative. Alrighty, the same as earlier, right? The flip of it, but it's going to be negative because of the negative sign. And last but not least, cosine t is the inverse of tangent of t. So what is the reciprocal of -1? Still -1, right? Flip it, 1/1, but of course the negative is still there. Regardless if it's on top or bottom, positive divided by a negative is a negative, so the whole thing is negative. Okay, I'm going to pause here because the next part we're going to use domain and periods of the trigonometric functions in order to evaluate and to simplify expressions using the fact that it's an even or odd function.